All right, so before we start biology, or the beginning of biology really is chemistry. And so we're going to have to know some basic chemistry facts in order to do some biology. And so this unit is basically learning about a little about chemistry so that we have a basis for our biology. So first of all, we're going to talk about the atom, specifically atomic structure. So the atom is made up of what we call three subatomic particles. They are made up of protons, which are positively charged, neutrons, which have no charge, and then electrons, which are negatively charged, right? And so where are these located? Well, protons and neutrons, which I'll call P plus, and so are no charge, and electrons are E minus. Protons and neutrons are found in the center of the atom, which is called the nucleus. So they are found in the nucleus. And then the electrons kind of are around, so there's all kind of like these rings, and the electrons kind of orbit around. So some people call this like a planetary model, where you have kind of something in the middle, like the sun, which we call the nucleus, with the protons and neutrons, and then on the outside are the electrons. The second thing we're going to learn is if an atom loses an electron or gains an electron, it becomes charged. It can either become positive or negatively charged, and we call that an ion. So for example, let's say I have 3 protons and 3 neutrons in my nucleus, and then on the outside I had only two electrons. So you'll notice I have 3 pluses but only 2 minuses. So this will be an ion. It will be a positive ion because it has one more proton than electron. Okay. So the most basic form are elements. So atoms can make up elements, and so elements cannot be broken down further, and they're found in the periodic table. Well, if you put multiple elements together and they combine chemically, or they bond chemically, we form what are called compounds. Some of the most common compounds are like water or carbon dioxide. And so in this case, they're always in a definite ratio, so always in a specific ratio. For example, in water, where H2O, for every 2 hydrogen atoms, you always have 1 oxygen atom. Or in carbon dioxide, for every 1 carbon dioxide, or 1 carbon atom, there's always 2 oxygens. Here you see there's a 2, and then if there's nothing there, we just think of it as a 1. So if it's blank, it's 1. So these numbers down here are what are called subscripts. You don't have to know that, but just know that they're in specific ratios. Well, how are they held together? How do they combine, and how are they held together? And those are through bonds. And there's 2 types of bonds. One is called ionic, and the other is called covalent. So ionic is when you have ions that are formed. So one really common example is sodium chloride. Sodium chloride is a ionic compound. Why? Because you have an ion, so this charged, and chlorine, which is negatively charged. And if you have a positive and negative, they're attracted to each other. And so an ionic bond occurs when electrons are being donated. Covalent bonds, which we'll talk about more, is when you share electrons. So the common covalent compounds like water or carbon dioxide are, in these cases, so we can draw a water molecule looking like this. And so in these cases, this bond, or the connection here, is covalent. Why? They're sharing their electrons. Whereas between sodium and chloride, this is ionic. The bond is ionic. Why? Because their electrons are being donated. They're not being shared. So one's getting it, the other one's donating their electrons, the other one's receiving or taking all the electrons. All right. Well, how do we make compounds? And so we can make compounds through what are called chemical reactions. And so this is a process where atoms or substances are reorganized into different substances. So for this to occur, bonds will break and form. Okay. So you can make a new substance. But in a chemical equation, none of the atoms are destroyed. It's just they're rearranged. So I want you to highlight reorganized or just think rearranged. Let's think. Let's do something very simple. So let's say we have sodium bromide plus chlorine. So in this chemical reaction, what I want you to see is sodium was with bromine, but after the chemical reaction, sodium and chlorine actually joined together, bonded together, and then bromine got kicked out. So it's just kind of like a rearrangement, right? Okay. All right, so to show chemical reactions occur, we use what's called chemical equations. A chemical equations basically has a reactant side, which is the left. This is what you start with, and the product side, which is the right. In the middle, it's called a yield sign. This is called a yield sign. So reactants are like what you start with in your chemical reaction, and the products are what you end up with. And so reactant is your starting substance. Product is what you form after the reaction. So in this case down here, this is what we call your reactants. It's what we start with. So we start with C6H12O6, which is glucose. And then in 6O2, this is oxygen, right? And then here are your products, carbon dioxide and water. So here are your products. And this is carbon dioxide and water. Okay. All right. So there are some special type of compounds. Remember, compounds are two or more elements chemically bonded together. One is an acid and one's a base. So a lot of things we're familiar with that are acidic, like lemons or anything that's citrus. Coffee is acidic. So it's a substance that releases hydrogen ions in water. So if you put like a lemon in water, it's going to release what we call H pluses or hydrogen ions. And so hydrochloric acid is stuff we put in our pools. It releases H plus and chlorine. And then a base releases hydroxide ions. So example of bases are like soap or milk. Those are bases. And NaOH, sodium hydroxide, can break down into sodium plus and OH minus. Notice it makes OH minus, whereas acids make H plus. And so with acids and bases, we have to understand what pH is. So pH measures the acidity or basicity of compounds. And so all we have to know is the pH scale. So it goes from 0 to 14. 0 is the most acidic, 14 is the most basic. So 7 and below is acid, 7 is neutral, and then above 7 is a base. Okay. And then our blood is actually around slightly basic. So it's 7.4. Okay, hopefully that helps.